Welcome back to Step Electrical friends. We are here in mesh analysis series and this is a part 2 of mesh analysis series. In this part we will learn how to solve type 1 circuit. So let's start. Okay friends, the title of this video is mesh analysis of the circuit containing only voltage source, and here the figure is that this is a circuit containing only voltage sources along with the resistors. So we can see that there are three loops. This is the first loop, this one is second loop, and this is the third loop. We can also say this is the first mesh, this one is second mesh, and this is the third mesh. So there are three loops, or we can say there are three meshes in this circuit. So first of all, we will assume that this is the first loop, and this one is second loop, and this one is third loop. So this is the first loop, this one is second loop, and this one is third loop. Okay, now it's time to assume the current. So we will assume I1, I2, and I3 be the current flowing through the loop 1, 2 and 3 respectively, but in clockwise direction. So we have assumed I1, I2 and I3 be the currents flowing through loop 1, 2 and 3, where these currents are flowing in clockwise direction. Okay, so this is the very first assumption that we have to do in every mesh analysis. The next thing is how to write KVL equation. Before writing KVL equation, as we know that we will apply KVL in mesh analysis, we will apply KVL equation in each loop. So the very first thing that you have to understand how to apply KVL equations, where there is potential drop, where there is potential rise. So let's talk about sign convention, and in sign convention for voltage source or the battery, we can see if the current of the loop is flowing from negative terminal of the battery to the positive terminal, then there is potential rise in the voltage source or the battery. So we can write plus V, and its reverse is if the current of the loop flows from positive to negative, then there is potential drop. So we write minus V. So this is about voltage source. And for resistors, in this loop you can see that this is connected with positive, and as this is positive, then the other terminal will be negative, and the current is flowing in this direction. So there will be potential drop. Now we are confident and we are able to apply KVL equation in each loop. So let's apply KVL equation in loop 1. Once we apply KVL equation in loop 1, we can write V1 minus I1 minus I3 into R1 minus I1 minus I2 into R2 is equal to 0. Again, you can see that this I1 current is flowing from negative terminal of the battery to the positive terminal, from negative to positive, and so there is potential rise. So we can write plus V1, and this resistor, for this resistor there is potential drop, so we can write minus I1 minus I3 into R1. And one thing that you have to think, why I1 minus I3? Why not I3 minus I1? As we are applying KVL in loop 1, we have assumed that I1 is greater than I3, or I1 has the highest priority, or the magnitude of I1 is greater than I3. So the current will always flow through this R1 in clockwise direction. That's why we write I1 minus I3 into R1. Similarly, for this R2, we will write I1 minus I2 because we have given the priority to this I1 current for loop 1. On simplifying, we can write minus R1 plus R2 into I1 plus R2 into I2 plus R1 into I3 is equal to minus V1. So this is the first equation. And let's apply KVL in loop 2. Once we apply KVL in loop 2, we can write minus V2. Here it is V1. Once we were applying KVL in loop 1, it is V1, positive, but here it is negative. So let's see. The current is flowing from positive terminal of the battery to the negative terminal. That's why we can write minus V2. And for resistor, it is same. There is drop, that is I2 minus I1. But this one is minus I2 minus I1 into R1. Why I2 minus I1 into R1? Because we have assumed for loop 2, as we are applying KVL in loop 2, we have assumed that I2 has the highest priority. We are giving I2 as the highest priority, or it is the highest. We are giving I2 the highest priority. So I2 is greater, and we will write I2 minus I1 into R2. Similarly, for R3, we write I2 minus I3. And there is drop, so it is negative, is equal to 0. On simplifying, we can write R2 into I1 minus R2 plus R3 into I2 plus R3 into I3 is equal to V2. So this is the second equation. Let's apply KVL in loop 3. So on applying KVL in loop 3, we can write V3 minus I3 into R4 minus I3 minus I2 into R3 minus I3 minus I1 into R1 is equal to 0. Here V3, why? Because the current is flowing from negative to positive terminal of the battery, so it is positive. And minus I3, here the I3 is the single current flowing through this R4, so it is minus I3 R4. And minus why? Because there is potential drop. Okay, so for R3 we write I3 minus I2 into R3. This is the potential drop in this R3 current. I3 minus I1 into R1 is equal to 0. So on simplifying, we will get R1 into I1 plus R3 into I2 minus R1 plus R4 plus R3 into I3 is equal to V3. So we have got three equations and there are three unknown values, that is I1, I2 and I3, and these all three equations are linear equations, and using calculator we can easily solve these linear equations. So on solving these three equations we will get the values of I1, I2 and I3. Now it's time to solve a numerical, and in this numerical you can see that there are voltage sources and whose voltage are also given, and there are resistors whose resistance are also given. So on applying KVL in loop 1, we can write plus 20 minus I1 minus I3 into 5, or minus 5 into I1 minus I3 minus 8 into I1 minus I2 is equal to 0. So we can write 20 minus 5 I1 minus I3 minus 8 into I1 minus I2 is equal to 0. So on simplifying we can write minus 13 into I1 plus 8 into I2 plus 5 into I3 is equal to 20, and this is the first equation. So let's apply KVL in loop 2, and once we apply we can write minus 5. Here why minus 5? Because the current is flowing from positive to negative, so it is minus 5 and minus 8 into I2 minus I1 minus 8 into I2 minus I1. Why I2 minus I1? Because we are applying KVL in loop 2 and I2 is the current of loop 2. Minus 4 into I2 minus I3 minus 4 into I2 minus I3 is equal to 0. So this is the KVL equation for loop 2, and on simplifying we can write 8I1 minus 12I2 plus 4I3 is equal to 5. So this is the second equation. 10 minus 6I3 minus 4I3 minus I2 minus 5 into I3 minus I1 is equal to 0. And on simplifying we can write 5I1 plus 4I2 minus 15I3 is equal to 10. So on solving these three equations we can get the value of the current. I1 equals 6.34 ampere, I2 equals 5.199 ampere, and I3 equals 4.167 ampere. Okay, do it yourself. Okay, so this is the figure of the circuit, and you have to find out the values of the current in each loop. So I will only provide you the hints, and the hints is very sufficient to solve this numerical. Thanks for watching this video till the end. So please like this video, share this video with your friends, and drop your valuable comment in the comment box. And if you haven't subscribed this channel, please subscribe this. Hope see you in next video.